Alrighty, part 1 for vertex form is choosing the equation. So first of all, vertex form is y is equal to ax minus h squared plus k. So I decided to go with y equals 0.5 parentheses x minus 0 parentheses squared minus 4.5. So that's part 1. Alright, now part 2 for vertex form. We're going to be looking for the vertex of this equation. So we're going to look at the h and k values. So we have 0 and negative 4.5. So when we're looking here, we're going to go to 0, and we're going to go 1, 2, 3, 4.5. So right about there is where our vertex is going to be. Alright, part 3 for vertex form. So we're going to be looking for the axis of symmetry here. So what we're going to be looking for is we're going to first take a look at the h value, because the vertex is your middle of the parabola. So, and the axis of symmetry makes it so if you were to fold the parabola over on to its other side, it would be the exact same, or you can also think of it as cutting it exactly in half. So we're going to be looking where it is on the x-axis here. So it is on 0, which is also our h value. And then you're going to simply draw a vertical line straight through it. So that is our axis of symmetry, because then the parabola will look something like that later. It'll go through it, right? And then you can see it folds over on itself. All right, part 4 for vertex form. We are looking for the zeros now. So what we're going to start with is we're going to put y is equal to 0 first of all, and then we're going to use the square root method for this one. So we're going to start out by trying to get this section by itself. So we're going to add 4.5 to get rid of that. So we're going to add it over here. 4.5 right there, all right. And then we have to get rid of this, but this is being multiplied to this. We have to divide. So we divide by 0.5, which means we have to do it here as well. So that becomes 9. So now let's rewrite this here. X minus 0 squared. Now we have to get rid of the squared to cancel that. We're going to square root, so that cancels. And x minus 0 is just x, so we have that. And then we need to do that same thing over here. And the square root of this is 3, but we have to remember the plus minus. So we have plus or minus 3 is equal to x. So our x's are either plus or minus 3, exactly what it says. So one of our x's is 3, and the other one is negative 3. So now we have our x's for our graph. And to just sum it up, we have our x's are 3 and negative 3, our vertex is 0 and negative 4.5, and our axis of symmetry is on 0. So you can see right here is 4.5, excuse me, negative 4.5. We have negative 3 here and 3 here. And then, of course, our axis of symmetry goes here. So that's what this parabola would look like for vertex form. All right, the next step is domain and range. So when looking for the domain, we can see this is going in both directions here. It's going to hit every single one of these numbers. It's going to hit every positive and every negative for infinity. So the domain is going to be all real numbers. And when we're looking over here, once again, the range, where it's going to hit on the y-axis here, it can't go any lower than negative 4.5. So it's going to be negative 4.5 and greater. So everything above 4.5, but nothing below, negative 4.5. All right, when considering the y-intercept and calculating that, we're just going to simply put our x, we're going to set that to 0. So, and then we're going to solve for y. So 0 minus 0 is obviously 0, and that is just 0, and then that is just 0. So all this just gets canceled out. Y is simply equal to 4.5. So that is our final answer. Pretty simple calculation for that one. And that can be shown here, once again, with our vertex here. You can see it's negative 4.5 is where it touches the y-axis. And our final piece, looking at the transformations here, as you can see, the parent graph is the one in yellow there, and the new one is the one in pen. And you can see here that it has translated down to 4.5 from 0, and it has also dilated and got a little bit fatter than the original. All right, step 1 for intercept form. We basically just am choosing an equation here. So the basic equation is y is equal to a, x minus p, and x minus q. So I have chosen y is equal to 1, x minus 10, and x minus 2. So that's what it looks like right there. All right, step 2 for intercept form, we are graphing the x's. So our p and q are what our x values are going to be. So that is 10 here and 2. So we're simply going to find 1, 2, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 right here. Okay, so it's kind of hard to see with this, but here's another visualization of it. You can see it's at 2 and 10, so those are our x values on the graph. All right, so step 3, we're looking for the axis of symmetry. So what we're basically going to be doing is taking this point and adding it to this point and dividing by 2 to find the exact middle here. So we are going to do, so 10 plus 2 is 12. We're going to divide that by 2, so that's equal to 6. So that is our axis of symmetry, yes. So it'll be 1, 2, 3, 4, 5, 6. Axis of symmetry will be right there, which that means our vertex is going to be on that line as well, which will be the next step. All right, the next step, we are looking for that vertex. So what we're basically doing here is plugging in our value we just found for this, which is 6. And we're plugging that in for x here. So we're putting 6 minus 10 times 6 minus 2. So this goes down, simplifies to negative 4 times 4. Multiply that simply, we got negative 16. So we're going to look way down here to negative 16. Add that right here. All right, and then we can connect. Let's see if I can do this. Ooh, there we go. Connect our, and make our little parabola there. So that is our vertex. So 6, negative 16. All right, step 5. Now that we have our parabola, we can decide if we have a maximum or minimum. And when we look here, if we look for a maximum, we really can't determine that because it just keeps going up and up forever. But we do have a minimum. This is the lowest this parabola is ever going to get here, which is negative 16. So the minimum for this parabola is negative 16. The most minimum value that you have to have there. All right, next we're looking for the y-intercept. So basically what we're going to be doing here is subbing in 0 for x because we're trying to find where it hits the y-intercept. So we plugged in 0 here. So we still carry the 1 over, so we just set it up just like this. And then we're going to simplify. So this basically turns 0 minus 10 is negative 10. 0 minus 2 is negative 2. So we are multiplying 1 times negative 10 times negative 2. 1 is basically nothing. Negative 10 and negative 2 is 20. So 20 theoretically should be our y-intercept. Now I didn't draw this graph exactly, so I pulled up Desmos over here so we can take a look. Oh, that looks lovely on my phone recording. This is the equation, as you can see here. And we graphed that here, and you can see it touches the y-intercept right exactly at 20. So that is how you find the y-intercept. All right, our final step for our intercept form is changing it from intercept form into standard form. So we're going to be using FOIL for that. So as you can see right here, the first, x times x is x2. And then the outside, x times negative 2 is negative 2x. And then inside, negative 10 times x is negative 10x. And the last, negative 10 times negative 2 is 20. We're going to combine these two in here just to simplify to negative 12x and put it all together. So we have y is equal to x squared plus 12x plus 20. Let me make a nice correction right there. That is a minus. Alrighty. All right, step 1 for standard form. So we're basically writing the equation here once again as the other two. So our standard form is y is equal to ax squared plus bx plus c. So we have y is equal to 2.5x squared minus 5x minus 7.5. Alrighty, step 2 for the standard form is finding Oh, I have to look at my paper. The axis of symmetry, yes. So, we're going to be using this equation here, which assists us in doing that. X is equal to the opposite of b over 2 times a. So, if we look over here, our b is -5, and our a is 2.5. So, we need our opposite of b, which is -5, so that means that it's 5, because that's the opposite, over 2 times a, 2.5, so 2 times 2.5, which simplifies to 5 over 5, which equals 1. And let's transfer that over to our graph. You can see here's 1, and along the orange dotted line there is our axis of symmetry. All right, our step 3 is calculating the vertex. So what we are going to do, since we already have 1 as our line of symmetry here, which shares the same thing as the vertex, so that's 1, that's what is in common there. We have to find the other value. So we're going to plug in 1 for each of the x's here. So you can see 2.5 times 1 and -5 times 1. And simply calculate that, and that'll give us our y value here. So obviously, 2.5 times, well, 1 squared is just 1, so 2.5 times 1 is 2.5. -5 times 1 is just -5, and -7.5 is carried down, simplifies to -10, so that is our value. So we have 1, -10. So we're going to look again on this line here, and we're going to find -10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, way down here. So that is our vertex right there. All right. Alrighty, now we're going to be calculating the zeros, which is a very long process. So here we go. We're going to first start out with choosing to use our quadratic formula here, which is x equals opposite of b plus or minus square root of b squared minus 4ac over 2a. So let's get started. So first of all, we recognize here that our, we have to put this equal to 0, of course. 2.5 is our a. -5 is our b, and -7.5 is our c. So I plugged it in all over here, so we have our 5 plus or minus square root of 5 squared minus 4 times 2.5 times 7.5 over 2 times 2.5. So that's me plugging in the b's and the a's and all that in the right positions there. The next step, I just simplified a little bit. So we have 5 plus or minus square root of 25 plus 75 over 5. And then over here, I simplified that to square root of 100 here, because 25 and 75 is 100. And then I simplified even more over here. Square root of 100 is, of course, 10. So we have 5 plus or minus 10 over 5. So now here's where we get our zeros. So 5 plus 10 is 15, and we put that over 5, and we get our product of 3. And then 5 minus 10 is -5, put that over 5, and we get a -1. So that's where we can look here. You can see we have a point at 3 there. My line doesn't even go through it, but that's okay. And -1 there, and of course our -10 vertex there. So that gives us our standard form parabola. We got our x's, we got our vertex, got everything we need. All right, our next step is taking a look at the intervals of increase and decrease. So we got our graph up here. We always look from left to right. So if we're looking from left to right here, you can see it goes downwards. So that's a decrease at first, and then it swoops back and increases going that way. So it goes decrease and increase. So those are our increase and decrease intervals right there. All right, next step, we're looking for our y-intercept of the standard form parabola. So we are going to simply plug in 0 for each of our x's, because we are trying to find the y once again. So obviously 0 and 0 and 0, it's all 0 there. -5 times 0 is 0 there, and we have our lonely -7.5, which comes over here. We got all zeros there, so it comes down to y is equal to -7.5. Desmos is coming to the rescue here again to show us that and prove it here. Here is my equation, which is the same as what we saw on the board there. And we can look right here. -7.5 is where this parabola touches the y line here. So that is our y-intercept. All right, the final piece to this, we're going to use Desmos here to help us explain and visualize this. So we're looking at the a value and how that affects the graph. So here is our equation. This is just the equation that we've been using for this problem. And we can take a look at how the parabola is here. Let's change this to 10, for example. So we changed the a value from 2.5 to 10. It gets skinnier, so it has a vertical stretch. It gets shorter in size there, so it gets slimmer and taller as the a value increases. So it narrows down as the a value increases. Let's put this at 1, for example. Here, I'll put it back at 2.5 so we can visualize that. Here's where we started. Let's put it at 1. So it becomes longer, but also wider. So it has a horizontal stretch as the a value decreases. So that is how that works. And that's the end of the video.